Let's talk about the Matlab-Backslash-Operator and why it was a risky decision of the makers of Matlab that it does as it does. Okay, let's start with an example. Let's say we have the following system and the following right-hand side. And now let's get the solution of this system. And we can use that operator. So if we have the coefficient matrix A, and if we have this right-hand side, then this x, which we get by A backslash B, then this x is the solution of A times what is B. So let's test A times x should be B, 153, and this is indeed true. Okay, this is the syntax of the backslash operator. And so far we have nothing what is risky. But in the last video we learned that overdetermined systems can also be solved using that backslash operator. Let's have an example. And now we have more equations than we have unknowns, and we have a right-hand side according to the number of rows in A, and then the backslash operator, this operator here, gives us this solution. But is that really a solution? We will see. Let's test A times x, and it's not 153, but 2.1, 4.4, and 3.1. We are somehow close, and this is the best leveled out solution. So every other solution or approximation to a solution will get a deviation to 15x measured in the Euclidean norm, which gives a greater value than we get when using this x. So this is the best solution, the best approximation to something like a solution. But it's the same operator backslash, and I think this is a bad idea. Let's have two more examples with this backslash operator. Okay, once again the backslash. Now we have an underdetermined system, so we have only two equations and three unknowns. Then Matlab, the Matlab command backslash, gives us that solution. Is that really a solution? Yes, this time it is a solution, but there are infinite many solutions. So instead of this solution, there would be a bunch of solutions, a lot of infinite many solutions, which all give A times x is 1, 5. And following some criteria, one of these infinite many is chosen. And as far as I remember, in Matlab, this solution is chosen in a different way than in Octave. So if you try that code in Matlab or if you try that code in Octave, will give you different answers. I am using Octave right in the moment, so Octave gives me this answer. So also for underdetermined systems, we have the backslash operator A backslash B, which produces a solution. And I think this is a very risky thing, that we are using the same operator for quadratic systems, for overdetermined systems, and for underdetermined systems. Let's close these examples with one more. This matrix A is a square matrix, but it's a singular one, determinant 0 matrix. And so we will see with this right-hand side. There is no solution in this case because this is a determinant 0 matrix, and so for most right-hand sides we can't fulfill this. And Matlab tells us at least, so it will return a solution, which is that one, but on the display there's at least a warning. But if we do that inside code, a lot of code, then this warning is displayed, but internally the calculations will not be stopped, so we will get some funny or some wrong answers in the end. Exchanging the right-hand side, in this case this matrix is singular and there are infinite many answers, and in this case we get one of these infinite many answers, and we get this warning. I think it's a very risky decision that Matlab gives us a command which can be used in 3 completely different situations. I think if you are a user of Matlab, you should know in which situation are you. Do you deal with a quadratic system? Do you deal with an overdetermined system? Or do you deal with an underdetermined system? And if you know that, I think it would be better to have 3 different commands. But why do I say that? Maybe you say it's a convenient thing. Why should I remember 3 different commands? But I think this is a very poor argumentation. And I want to show you why I think so. Here I have some code which implements the following. Given x and given y, we are looking for a polynomial which interpolates these 4 points. And I do that with this nested loop. Instead of that, we can use polyfit. There's a command in Matlab, but let's assume that you don't know that, and then maybe you program it like that. Then here you build up a matrix A, here you build up a right-hand side B, and here you get K, the coefficients, the solution of A times what is B, and these K's are the coefficients of the polynomial interpolating these 4 points. And now we will plot. First we plot the problem and then we plot the solution, and let's run that code. And as you can see, the program does as it should. We are interpolating using a cubic polynomial. We are interpolating these 4 given points. So it's no problem. But what if there was a mistake in your code? Maybe you did not want to, but you typed in n-1 instead of n. Then A will have 1 row less, and we have an overdetermined system. Let's check what will happen and what is happening. The last point, x is 5 and y is 2, is forgotten. This point is forgotten, and we are interpolating with a cubic polynomial these 3 points. And there are a lot of polynomials of degree 3 interpolating these points, and one of these we get by using our backslash command. So in this case, I think it would have been better if Matlab gives me an error, wrong command. You wanted to solve a quadratic system, but you gave me a system which is not quadratic, and so this is the wrong operator or it's the wrong input. Okay, I think that would be more desirable. Okay, what happens if we have the error here? Now we are running only for K2, only till n-1. Let's run that code. This time we are doing the following. This time we are looking for a polynomial of degree 2, interpolating these 4 points. That is impossible. So the backslash operator here gives us a solution which is, there is some Euclidean deviation minimized, and so we get 1 polynomial of degree 2. I did not want to solve that problem. I misplaced a -1. It should have been an n without -1, but unintentionally I had n-1, and in this case we have an overdetermined system, more equations than we have unknowns, and in this case I would prefer an error message. Sorry dear user, maybe you used the wrong command, you wanted to solve an overdetermined system, but you used the backslash operator. Please use the command for overdetermined system, or you used the wrong input arguments A and B, and this is indeed the case in that example. So my clear advice to Matlab or Octave is abandon this logic. This was not a good decision. There should be 3 different commands and not a single one. But I know the rules of the game. If you had a version of Matlab using the syntax as we have it, then it's not easy to change that, because then a lot of programs need an adaptation, and no user likes that. Maybe there are thousands or millions of lines of code, and then you have to change that code, and so Matlab will never change that logic, although it would have been a better decision. But the feathers are out of the pillow, and so it will stay as it is. I would say it was a bad decision, and if I would have been part of this congregation, I would have voted against this logic in Matlab.